Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on February 8th, 2026, about 10 days ago. It introduces a 10-level taxonomy called data Darwinism and demonstrates that by using advanced models to refine scientific data, they achieved performance gains of nearly 3 points on general benchmarks and over 8 points on domain-specific tasks. The paper is titled Data Darwinism Part 1, Unlocking the Value of Scientific Data for Pre-Training. And as we'll see later, the findings reveal a massive learnability gap in raw scientific text that standard filtering simply cannot fix. And for those interested in the implementation, the authors have shared their code on GitHub. Over on Hugging Face, the 3 billion and 7 billion parameter weights are ready for download. You will find quantizations and usage examples to help you get started quickly. So, Figure 1 visualizes the data Darwinism pipeline. It depicts an evolutionary trajectory starting on the left with raw data, represented as rough stone blocks. As the pipeline progresses, processing becomes more sophisticated, transitioning from simple sorting to robotic refinement and advanced cognitive models. The central coevolution loop, marked by the blue arrow, shows how these models loop back to improve the data processing itself. Finally, on the right, this culminates in a synthesized world of high-quality data. Okay, Figure 2 details the full data Darwinism hierarchy, mapping 10 levels from L0 to L9. On the far left, L0 represents raw data acquisition, essentially scraping and extraction where noise is high. Across the top row, levels L1 through L3 handle standard cleanup, like formatting, normalization, and filtering out duplicates. The process deepens at level 4, generative refinement, where models actively rewrite text to standardized style. Crucially, level 5, or cognitive completion, uses advanced models to reconstruct implicit reasoning steps, which directly addresses the learnability gap. This path culminates in level 9 on the right, a fully simulated world for unlimited training data. Table 1 puts those definitions into practice, summarizing the statistics for the Darwin-Science corpus. In total, the dataset spans over 900 billion tokens. The content splits into books and papers, but notice the processing levels in the first column. While books utilize level 4, the papers are divided between level 4 and level 5. In fact, the level 5 papers alone contribute 440 billion tokens, meaning nearly half the training data relies on that deep cognitive completion. So, Table 4 reveals the payoff. It compares the baseline models against the Sci-Mix configuration using Darwin-Science data. In the General Tasks section at the top, performance improves even on broad benchmarks like MMLU and Big Bench Hard, where the 7 billion parameter model gains over 6 points. Moving down to the scientific tasks, we see strong results in medical question answering. But the in-domain tasks near the bottom show the real impact. The larger model improves by over 10 points on paper evaluation, confirming the data successfully bridges the learnability gap. Figure 6 tracks the training dynamics across 600 billion tokens. On the left, covering general benchmarks, the blue line for standard filtering barely separates from the gray baseline. In contrast, the green line, representing level 5 cognitive completion, climbs significantly higher. This advantage explodes in the right-hand chart for the domain-specific evaluation. Here, the green line dominates, proving that adding explicit reasoning steps unlocks far more learnability than simple text refinement. Wrapping up, the core takeaway is clear. Raw information density does not guarantee learnability. By systematically refining data with advanced models, specifically through that level 5 cognitive completion, we can unlock massive value hidden in scientific texts. This suggests a future where models and datasets co-evolve, moving beyond static web scrapes. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.